Hello everyone, my name is Fereshteh Sadeghi Naieni and I am just presenting the final project. Here is my agenda for this presentation. Now I just want to focus on the strategy to employ machine learning in a firm. First of all, I just consider that I was, hired in a Denton Cancer Center as a chief officer, data chief officer, and this cancer center is, has different divisions. Medical oncology, especially for, prescribing medicines for the therapy and or chemotherapy or hormone therapy, and surgical oncology that is related to the tasks of surgeries on the patients, and radiation oncology and diagnostic imaging that is related to the MRI or ultrasound images, and clinical labs that take tests from blood or other samples of the patients, and the research and clinical trial that is used for research purposes. This data center is, as an institution for treatment and diagnosis of cancer that I assume that it's about 150 employees and is directed by eight executive boards. It grows in a very competitive environment that we need to apply machine learning across the whole company. So I wrote a strategy for AI strategy for this problem that the major focuses are first on improving the clinical outcomes by using machine learning to early detection, to prediction of cancer recurrences, or provide personalized treatments. I also focus on the improving operational capacity by, by predicting the time scheduling and reducing the delays and optimizing the resource allocation, or improve the research outcomes by finding cancer biomarkers, or reduce the organizational expenses by automating the process or boosting the predictions. And finally, the increasing the patient satisfaction by enhancing care and outcomes for the patients. The main points of the strategy in a machine learning strategy in DCC are just divided in these six items. One of them is modernizing the data systems and infrastructure. The second one is using tools and technologies needed for machine learning. The third one is just focusing on enhancing staff skills and building machine learning expertise. And the fourth one is creating clear rules and standards for responsible and ethical AI. And the fifth is implementing ML projects across different departments and uses standardized ML project workflow, especially the reputed method CRISP. First of all, for modernizing data systems and infrastructures, I stated that it is very important that DCC can integrate electronic health records, laboratory information systems, and radiology information systems, and transfer all of these data to the data lake. And use such tools such as Databricks and Snowflake, and then and use also a hybrid cloud for having a secure environment for the data, such as Azure. And these data in these data lake, the data will be processed and organized, and then transferred to the data warehouse to use ML, machine learning operation tools such as ML flows to automate and feature engineering or automate predictions, or and also is also transferred the reports on the decision support layer for creating dashboards, applications, or other valuable insights for the clinicians. Another important point it is that it is very important that we have a data catalog that includes all lists of data sets for the staff that they need. Or we should have some use some meta standards metadata standards to increase the interoperability across the systems and protect the patient information by using HIPAA compliance, or just give some authorization to the users to the users that have allowance on some restricted data and sensitive data. For the second strategy, I use the tools and technologies that are needed for machine learning. And we know that if we want to track all the causal models, we need some tools like version control or Git. We need some machine learning operation tools or softwares in order to automate testing and deployment of models. Or we need to detect the errors in, like clinical use and monitoring them by monitoring the tools, or using some model registry tools in order to register all of the models, their versions, and their approval status, and tracking them constantly. Also, ML technology ecosystems, for the ML technology ecosystems, it is important to use, for example, Azure as a cloud, or Azure Data Lake as a data lake for storing clinical and imaging data, or use Databricks for analytic tools, for analytic purposes, or use ELT tools such as Airflow to automate data flows, or use machine learning operation, tools for like MLflow for model training, tracking, and deployment. We can also use Power BI and Tableau for creating dashboards and communicating insights with the clinicians, and or using image AI tools like Clara Medical in radiology and pathology. For the third strategy, enhancing staff skills and building ML expertise, it is very important we should train and have a chief data officer for monitoring AI strategy, have data scientists for build predictive models, or train machine learning models for monitoring pipelines, or data engineers for building data pipelines. We should have some expert people and clinical informatics experts in order to translate clinical problems into machine learning solutions, or have some AI ethics to monitor the safety and fairness of the machine learning models. Or we have some leaders to manage staffs and help them to adapt the change. So for the fourth, we should create some clear rules and standards for responsible and ethical AI. To ensure the patient safety, to maintain the fairness and transparency, to comply with HIPAA and new rules, and also create standardized documents for all models to track them and validate them constantly. It is very important to in this fifth strategy. It is very important to even implement ML projects across different departments, such as clinical oncology for treatment prediction, for in radiology for tumor detection, for in pathology for morphology analysis, for in clinical operations for scheduling optimization and reducing the expenses, and in the research for finding, for example, biomarker efficacy. And in the sixth step, it is very important to use a standardized ML project workflow and using such methods and reputed methods such as the quiz, because it helps us to understand the data, to prepare the data, and to go through this process to build a model, to evaluate it, and to deploy it, and repeat this process, and validate our models and update our models all the time. Now, for the part two, I just want to focus on the data pre-processing problem that we have in our project and the data set that we use in shelter animal data set. And first of all, I employ import essential libraries and modules and load the data set and handling the missing values by replace the zero values and use drop null methods in order to all of the null values in the data set. Then which I have to do save and extract the pre-processed data sets. So it's very important to decide on which columns should be remained in the final data set. First of all, we know that animal ID doesn't have any predictor characteristic. So I removed it. For the data, for other variables that were categorical, first of all, I converted them to numeric, and especially for the age open outcome, I converted to numeric, separating the descriptive and numeric variables, and then go through these loops and find how the animals according to year. And then I used a correlation map, a correlation heat map to present it. I mean, each of these variables have a correlation with the outcome type. And as you see, the date of birth has a correlation zero, but others have meaningful correlation. But all this correlation does not mean causation. So date time, which is the outcome date time or months per year, both of them are similar to each other, cannot have meaningful influence on the outcome type. So I removed those as well. And finally extract the related data set or clean data set in the sheltered animals tree. The third tree is regression models. So in this project, first of all, I want to build a machine learning model that predicts the age of avalanche through using physical attributes such as length, height, diameter, and weight. And the dataset contains 4,177 records and includes 8 predictors. An important point about this dataset is that it has a column called rings that it is useless, and we should just convert it to another column called age by adding 1.5 to it. So I do this and delete the ring columns, and also I explore manually all of the columns, checked for invalid values, and found that height has some zero values, and I put them and replace them with none. And finally, the missing values removed by using the drop null method. So the final data set just have 4,175 abaddons. And for the EDA or explanatory data analysis, I plotted all of the histograms, density plots, and box plot. As you see, and the length and diameter have distribution, and they are like real shape, and others are right skewed, are right skewed, and especially, for example, for the weights are very close to zero. It means that they are very light, and in the days also we have a lot of and for the age also we have a lot of outliers in the upper band, and in the diameter, as you see it, and in the length, they are more concentrated between 0.2 to 0.6. And for the age also, it is concentrated less than 20. It means that most of them are less than 20 years old. For the scatter plot, as you see, there is a strong correlation between all of the variables. Especially, it means that, for example, if the avalon has increased length or diameter or height, it will be it will be heavier, and also it will be older. So there are a very strong correlation between all of the variables, and between age and length, between the date and length, and the diameter and the height, and also um, and the length and the height. Now, after that, we want to plan the model and build the model. So our target variable is age, which is numeric, so we should use regression models. Here I use linear regression and decision tree, and but we can use other types such as random forest or support vector machine. And I use scikit-learn to build a model and split the data set by slicing two predictors and the target variables split the data set into test set by selecting 33% of the data set as a test set and 67% of them as the trained set. Use R square for the performance, for evaluating the performance of the models. And also finally, I showed the intercept and coefficients of the linear regression. As you see in this picture, the R square of the linear regression is 0.49 and the R square of the decision tree is 0.50. It means that a linear regression has better performance than decision tree, and it can predict with about 50% accuracy, but it doesn't mean that it is a very perfect algorithm, because about 50% of the response variable are not described by the predictors. And also at the avalanche, since the intercept is 4.7, the avalanche are started from 4 years old, and the most influential variable is height, and the least influential is sex. And after cross validation with tenfolds, I found that the MSE is the negative mean square error is 0.4 minus 4.9, and after calculating the R square, I found the R square is 0.52. It means the R square improved by 3%. Part 4, classification models. Now, we want to build a machine learning model to predict whether an individual's annual income is more than $50,000 or less than or equal $50,000. We use demographic and employment related attributes. And here is the classification problem, because we have two classes in the target variable. We also then have a data set include 50,000 records, and the income is the target variable. Numeric variables are age, weekly working hours, capital loss and gain, and categorical variables are these that you see in these slide, that we change all of them into numeric variables. But another important point about this data set is that some of the fields after grouping the categorical variables were found to have some abnormal values, such as question mark, that they should be cleaned or replaced. So income field includes, and also the income field includes a dot, that we remove this dot from that. After preparing pre-processing the data and cleaning the data, I plotted for the explanatory data analysis, I plotted all of the histogram, density plot, and box plot. As you see, age is right skewed, and most of them are young, less than, for example, 50 years old, and capital gain, capital loss are also equal, are concentrated very equal to zero, and the working hours are between 20 to 60. It means that most of them are full time. And another important point is that, for example, the density plot shows that age is like a normal have a normal distribution. And the box plot shows that, for example, capital loss and capital gain have a lot of, outliers in the upper bound, and and the working hours are more concentrated on this area, between the 35 to 45. The whole visualization shows that how many null values we have in each column, and we also use drop null method to exclude all of those, and the final data set and clean data set has 45,222 records and 14 fields. The goal of this project is to predict income levels. So it's a categorical variable, as I explained before, and I use logistic regression and k nearest neighbors with k equal to 7. The data set was split into predictors and targets, and all categorical variables were encoded numerically. And finally, the data sets, the 33% of the data set was selected as test set, and 67% of it was selected as the train set. The accuracy score was used as the evaluation, and the 10-fold cross validation was applied to improve generalization, reduce overfitting, provide more stable estimates of the model performance. Now, for the results, as you see in this picture, in this visualization, the k nearest neighbors has the best performance in terms of accuracy, F1 score, recall, or precision. So recalls mean presence, sensitivity, precision, and the F1 score is is the balance between recall and precision. So in all of those, k nearest neighbors have the best performance. So it was selected as the best performance model. For part 5, clustering models. In this part, I just want to apply unsupervised machine learning to the car evaluation data set in order to identify natural clusters of car characteristics. So the data set contains 7 attributes, of which 6 are used as predictors for clustering. All attributes are categorical and must be numerically encoded before applying k-means clustering. So these are the predictors of the data set. For the data preparation, we saw that the doors field had the category 5 more, so we replaced it with 5. In the passengers field, we also have category more that we could replace it with 5. And these replacements converted the original categories fields into numeric fields. For the explanatory data analysis, we created, box plots, histograms, kernel density plots, but we did not bring them here because the doors and I did not bring them here because the doors and passengers, does not have present continuous, does not have continuous numeric measurements, and their plots is like a line, and it doesn't show that there is a meaningful relationship between them, even in the scatter plot, or there is any specific distribution. I mean, statistical distribution is applied to them because they contain only fixed values. So for the model planning, first of all, I use ELBA method to find the optimal cut. In the ELMA method, the algorithm calculates within cluster sum of squares for different values. So it generally WCSS decreases when the car increases. And as you see here, we have a significant improvement. But after car equal to 3, the improvement is constant, are equals to each other. So I used car equal to 3 as the optimum car. And these are the centroids of the clusters. And maybe you ask why the visualization of the clusters are like that, because these clusters have 6 variables, 6 predictors, and if you want to put them in a two-dimensional visualization, and it cannot show all of the clusters and it cannot show all of the dimensions. That's why we do not see another cluster. The solution is to use a dimensionality reduction, such as principal component analysis, that I did not use in this project. So for the prediction, first of all, I use two predictions in order to predict according to this cluster. And as you see, for the first prediction, I assume that there is an automobile with a medium price, with a low maintenance, with four doors and a capacity of five passenger, and that a capacity of a small luggage, and with a medium safety. It categorizes at the second cluster. And for the predictions two, I assume that for the record two, I assume that a new record with a high price, with a very high maintenance, that it has five doors, fixed for five passengers, fixed for big luggage, and it has high safety, and it categorizes it as the you know uh, mm, the first cluster. Part 6 comparative models. Before I start part 6, I just want to give you a reminder about the two problems that we have. The regression problems that we want to predict the age of the avalanche according to their predictors. And the second one was to predict the income level according to the demographic or other occupational characteristics of the individuals. So I used again those two data sets in these comparative models. So I won't go through again the pre-processing of the models and talking about the bar plots. So for the first section, if I want to talk about the regression models, I used in that problem used linear regression and decision tree. But here I also applied random forest in order to compare the prediction of the age avalanche. The accuracy of prediction of age avalanche between these three models. And as you see, random forest has the best performance with 44 with about with 0.454 R square, and the symmetry is the worst one with 0.14 R square, and the linear regression has a 0.49. And there is a very slight difference between random forest and linear regression. And then I use tenfold cross validation to increase the to increase the performance of the model, and ameliorate the process of training. And as you see, after tenfold cross validation, the error for these, the mean square for these models are like, the ones that in these equations. And after that, I used this formula to find the R square, and the R square of random forest has been improved by just 1%. The R square of linear regression has been improved by just 3%, and the R square precision tree has not been improved at all. But the important point is that again, random forest has the best performance both from the mean square perspective and R square perspective. It was selected as the best performance. But I just want to use a prediction, a new record, by considering that we have a male abalone with this length 0.84, with this diameter zero point 0.4, with height 0.16, with whole weight 0.65, and with shocked weight 0.2, with vertical weight 0.16, and with shell weight 0.22. The logistic regression predicted the age equal to 14.2, and the decision tree 12.5, and the random forest 14.44. And as I explained, the random forest result is the most reliable, and we should use this as the correct answer. For the classification model, and as you remember the problem that I explained, we have two levels for the income. Again, I use logistic regression, k-nearest neighbors, and random forest. And again, random forest across all those classes and for the whole accuracy has the best performance in terms of accurate precision, recall, and F1S score. But the important point in this problem is that when using the q nearest neighbors, I didn't put the car equal to z7 by default. I used again a raw method and select 3 as the optimum car and then develop the k nearest neighbors model. Again, I used a prediction with and assume that an individual is 42 years old. That is a employment type of private, and it has education level of some college with most I mean education level of 10. That is marital status is married, and he's an executive manager, and he's a husband. He's white, and his capital gain is 68,000, and he's living in the United States with working hours 40. But all of these models, the linear logistic regression on random forest says that it belongs to the high level income, but KNN to the low level income. But we should select the random forest because the random forest presents the high precision, recall, and F1 score for this class. And finally, after using tenfold cross validation, again, the random forest get the best performance and accuracy among all, and then k nearest neighbors. Thank you so much.